When we looked at how to create data frames, we saw a way to send a CQL query to Cassandra and get a data frame back out of it. Now, what if we had, say, a few data frames lying around from a few different queries, and we wanted to use the data frame API to do the querying? What does that API look like? Well, it turns out it does a pretty good job of recreating the relational algebra that we would find in standard SQL. We're going to go over that API, show a few key methods in it, and you're going to see all of them look incredibly familiar from the standpoint of SQL. We won't give you exhaustive examples showing all of them, because if you know SQL, you probably have an idea how to do that already. I do want to show you what they are, point you at the documentation for further details, and show you a couple quick examples of how you might use them. These are methods we're going to call on a data frame object. If I've created a data frame based on some SQL query, I can, for example, do a projection on it. I can call the select method and create a new data frame that has only the columns that I pass into the select method. I can rename columns. If I've got a column in the source data frame that I don't want in the new data frame, I can rename that with the with column renamed method. I've got a distinct method that works a lot like select distinct in SQL. That's going to give me a new data frame that has only the distinct rows from the source data frame. If I want to do some filtering on a data frame, I've got the where method or its alias filter, and I just pass in conditions to that. If I want to do aggregation, like averaging or counting, I've got a method that lets me do that. I can group by, I can order by. Order by has an alias called sort. And finally, I can limit, just like I typically can in SQL. So a lot of this stuff, as I said, recreates a part of the relational algebra. Let's take a look at a few more methods and we'll get the rest of it that might be missing. And here we are with join. And this is a method that gets a lot of people excited. Of course, it's a thing that exists in the RDD API, but it also exists in the data frame API. You call this on one data frame, you pass in the other data frame, potentially giving it a join condition and a type. Now that type lets us switch between inner and left outer and right outer type joins. Clearly here in the slide, we're not giving you the whole API. You want to consult the Spark documentation for that. That's always the best source to go to, but this gives you an idea of how to get started. We also have the union all, intersect, and accept methods. Union all gives us a data frame that has rows that are a combination of the source data frame and the other data frame, as long as they're union compatible. That is, as long as they have the same primary key. Similarly, intersect is going to give us a data frame that has the rows that occur in both the source and the other data frame. Accept is kind of the opposite of that. It's going to give us all the rows that are in the source data frame, but not in the other data frame. And just look at all these supporting functions. I'm not even going to read through all these. You can see there's a tremendous number of them. And to learn how to use each one, please consult the documentation. But this lets you know this is a pretty serious API. Once you get a row out of a Cassandra table and you've got it in a data frame, there's a lot of work you can do with it. All right, let's just show a quick example of how to use a little bit of this. Again, exhaustive examples would take forever, and this is the kind of thing you want to read the docs for to dig into in detail, but let's take a look here. Now, we're going to use the read method on the Cassandra SQL context and tell it that we want all of the rows from the movies by actor table in the killer video namespace. And that's it. We're going to load those. Those are in our data frame. Now let's walk through this code. Now you can see we're doing SQL-y kinds of things. We're using the relational algebra on this data frame and creating new data frames as we walk through each method call of this Fluent API. So the first thing we're going to do is filter. That's a lot like the where clause. We want everything where the actor is Johnny Depp. Then we're going to group by the release year. Then we're going to do two aggregations. You recall seeing that aggregate method a couple of slides back. What you do with the aggregate method is you give it a map. You give it key value pairs. The key in each case is going to be the column name that contains the result of the aggregation, and the value is going to be the type of aggregation function to run. You see we're counting and we're averaging, so we're returning two aggregate results for each group. However, we don't like the default names. Count one and average rating, those lack a certain panache, so we're going to rename those to total movies and average rating, respectively. That data frame that we've got at this point, and if you're typing this into a Spark shell, you'll be able to stop the code at that point, run it, and see what the schema is, but that's got columns in it that we don't want. So we're going to call select, and we're just going to take out release year, total movies, and average rating. Those second two being the newly renamed columns that we've just created. Then finally, we're going to do some ordering. We're going to order by total movies first and average rating second, limit it by 3, and finally show it. And that show is going to trigger the computation and dump the results out in tabular form to the screen, just like you see on the slide. And look at that, we've got 3 release years, 2004, 2000, and 2011 shown. That's because, remember, there are other release years in the dataset, but we're limiting by 3 and ordering by total movies descending. So these are the 3, if you will, most productive Johnny Depp years that we've got in the data. Those second 2 years, 2000 and 2011, both had 3 years in them, so those rows get ordered by the average rating of the films released in those years. Now, as a SQL query, this is intermediate at best, right? This is not a particularly complex thing if we did this in ANSI SQL. It's the kind of query that relational database developers do all the time. And Cassandra users have a tough time with in CQL. This is a thing we would have to come by some other way, but it's actually pretty easy to do in Spark SQL. We get access to meaningful analytic capabilities with a pretty simple API.